All right, welcome back. We've got a couple more problems on your guided practice to go over. The first ones that I want to do is working backwards. So working backwards means I'm going to give you a volume and you're going to have to find and identify some kind of dimension. So in this case, it says find the side length of a square prism with a volume of 147 and a height of 3. Now the big thing to remember here is that a square prism has a base that's a square, obviously. I'm really bad at drawing square prisms. Okay, so because it has the base of a side of, because the base is a square, that means that the length and the width are going to be equal. So instead of saying length and width and treating them as two separate variables, I'm going to say side squared. And you may have seen area equals side squared, that formula before, when you're learning about area of a square. So my volume formula, volume equals length times width times height. But again, we said we're going to call length side squared times height. Now you're ready to substitute the values that you know. So 147 was my volume. I'm setting that equal to the side squared. The height is 3. So to solve this, side squared and 3 are being multiplied. So the opposite of multiplying is dividing. 147 divided by 3 is 49 equals side squared. Square root both sides, so the side has to be 7. Which means that the length is 7 and also that the width is 7. Okay, for this next one, find the height of a square-based pyramid. So again, we've got another square-based pyramid. And it has, we want to find the height, we don't know the height. The volume equals 242, and the base length, so the base length is 11. But we also know that since it's a square, that the base width is 11. So again, we can substitute that value. We have 1/3 length times width times height. 1/3 because it's a third of a square prism. The length and the width, again, are going to be side squared because the base is a square. So volume equals 1/3 side squared times h. Now this time, I can have volume equals 1/3 times 11 squared times h, and I actually can substitute the volume in for the v, so 242. Now I know I can plug this into my calculator and solve that way, but multiplying 121 by 1/3 is going to give you a decimal. So instead of doing that, you can divide by 121, divide by 121. That gives you that 2 equals 1/3 times h. Instead of dividing by 1/3, we can multiply by 3 on both sides. So 6 equals the height. All right, for this next one, we have Cavalier's principle. Cavalier's principle, if two three-dimensional figures have the same height and the same cross-sectional area. So if you were in class, you've heard about this before, but if you're not in class, think about cross-sectional area as being like a Post-it note, like a packet of Post-it notes. Each Post-it note is we can find the area of each Post-it note. When I stack those together, I've got a bunch of cross-sectional areas, and then I have a height of a cube. So that's kind of like what we mean by cross-sectional area. Now, if you are someone who loves Thanksgiving, you've probably seen before the can of cranberry that look, some people either really, really love it or some people really hate it, but you've seen a can of cranberry. And this can of cranberry, it's like if you put it on a plate, it would just stand as a solid and it looks all kind of nasty. But it's like Jell-O. So your cranberry can jiggle and it can kind of sway. It can jiggle to the other side and it can kind of sway. And basically that is Cavalier's principle. If I have something that's jiggled a little bit to the left, has the same height, but it has the same cross-sectional area, meaning each of those little circles that I would cut into millions of little slices, if they have the same area, then the two shapes are going to have the same volume. So you're looking at two examples here. I've got a little tilted triangular prism. The prism is tilted, but these heights are going to be equal. So since the heights are equal and these two triangles are the exact same, meaning they have the same area, that means the volume is equal. And similarly, this is kind of like my can of cranberry. It jiggled a little bit over. It's still the same height, but these two circles have the same area. So the radii are the same. So compare a cylinder with a base of 3